Well, hello, calculus students and seekers of general truths. In this video and then the rest of this lesson, we will learn some integration techniques for some expressions that are maybe a little bit more complicated. But really what this lesson is about how do we handle complicated algebraic expressions. We can reduce a lot of our work here, not from the calculus right down to the algebra. So let's review very quick and let's look at a warm-up question and then we can connect this to the rest of the problems in this lesson. So let's combine this into a single fraction. Right? So we want to get the same denominator. So we have 1 over x plus 2 minus 3 over x minus 5. So if we want the same denominator, then let's multiply the first fraction by x minus 5 over x minus 5. And then multiply the second fraction by x plus 2 over x plus 2. And you can see that when we do that, we end up with the same denominator. Our denominator is going to be x plus 2, x minus 5. Okay, so this is going to be the same thing as this one once we multiply it out. And in our numerator, we are going to get 1 times x minus 5. And then negative 3 times x, negative 3 times positive 2. Okay? And then we can simplify this down a little bit further. Excuse me. In the numerator, we are going to have negative 2x minus 11. And in the denominator, we are going to have x squared plus 7x. Excuse me, not plus 7x. It's going to be minus 3x. And then minus 10. Okay. And so this is our final answer. All right. Now, when I first saw this type of problem, and perhaps you're thinking about it too, the question is, what does this have to do with calculus? All right. So let me get right to it and give you a very, very brief explanation to that. So suppose I asked you two questions, and the first question was, find the antiderivative of negative 2x minus 11 over x squared minus 3x minus 10 dx. All right? And you can see from this problem, it's going to be kind of a complicated process. There are certain things in here that you're not going to be able to handle. There are certain operations in here that can be very difficult to do. So we're finding a function whose derivative is this expression. All right? But what if I were to ask you an alternative problem? Can you find for me the antiderivative of 1 over x plus 2 minus 3 over x minus 5 dx? And I hope you see and you remember at this point that this second expression here is much easier to find the antiderivative of than this first expression, right? But if you compare the two of them, they're the exact same problem. We started with this expression and we ended up with this expression. So they're the exact same expression, just written in a different way. And the way that we write it here, when they're all combined together in a single fraction, is pretty hard to integrate. The way that we write it here in the second fraction is relatively simple to integrate. So we can say that this first complicated thing is equal to this second indefinite integral, and its antiderivative is the natural log of x plus 2 minus 3 times the natural log of x minus 5, excuse me, and then plus a constant. Okay. And so the rest of the lesson is going to be focused on this. How do we, if we're given something complicated like this, how do we break it apart into something that is a little bit simpler? So there we go. Hope you're all nice and warm after this example. Let's continue with the other videos and apply this to some of our more complicated problems.